Part 1. The limits of science. Why science can't answer life's biggest questions. The edge of knowledge. What if science isn't the crowning achievement of human understanding, but rather the beginning of its limitation? We live in an era where science has provided extraordinary insights. It has given us vaccines, connected us via satellites, and taught us how to edit genes and manipulate atoms. Artificial intelligence now writes poetry, drives cars, and simulates empathy. And yet, for all its power, science stops short at the threshold of the most meaningful questions. Questions like, who are we? Why are we here? What is consciousness? What does it mean to suffer, to love, to die? This episode of Philosophy Point is not an attack on science, far from it. It's an invitation to recognize its boundaries, and beyond those boundaries lies a terrain far more mysterious, profound, and ultimately personal. Part 1. Measurement, limits, what can't be measured. Science begins with measurement. What cannot be measured, many argue, cannot be known. But what if the most important things in life defy measurement? Take consciousness. You know you are aware right now, aware of these words, this voice. But no brain scan, no electrode, no algorithm can measure that inner light. It's what philosophers called qualia, the raw, subjective experience of being. Sir Roger Penrose, the renowned Oxford physicist and mathematician, co-authored the Ork-Ore theory of consciousness with Stuart Hameroff. Penrose, in his landmark book The Emperor's New Mind, argued that consciousness cannot be explained by classical physics or computation. Instead, he proposed that quantum processes inside neurons may hold the key. This is not fringe speculation. Penrose won the Nobel Prize in Physics in 2020 for his work on black holes, and his view is shared by a growing number of scientists and philosophers who believe that inner awareness cannot be reduced to data. And it's not just consciousness. Can we measure love, grief, awe? We can track hormone levels, brain waves, or facial expressions, but we're left with shadows. As physicist Richard Feynman once said, you can know the name of a bird in all the languages of the world, but when you're finished, you'll know absolutely nothing whatever about the bird. And as Ludwig Wittgenstein, the Austrian-British philosopher of language, once wrote in Tractatus Logica Philosophicus, whereof one cannot speak, thereof one must be silent. But must we be silent? Or must we learn a new language, not of measurement, but of meaning? Part 2. Experimental limits, ethics, scale, and irreversibility. Not all things can be tested. Some are too large, too distant, too dangerous, or simply too sacred to probe. Consider the origin of the universe. We can observe cosmic background radiation. We can theorize inflation, singularities, multiverses. But we cannot rerun the Big Bang in a lab. Charles Darwin, whose On the Origin of Species revolutionized biology, showed that life evolves through natural selection. but evolution plays out over millions of years. We can simulate it in bacteria, in code, in models, but we cannot recreate the full sweep of evolutionary time in controlled conditions. Even closer to home, many of the most urgent questions, climate change, societal collapse, ethical systems, resist experimentation. We cannot build alternate Earths to test different carbon outputs. We cannot subject societies to genocide and trauma for the sake of understanding human psychology. To do so would be monstrous. And so, science leans heavily on modelling and simulation, tools that are essential but inherently speculative. The climate models, for instance, of the Intergovernment Panel on Climate Change, are among our best tools for predicting future outcomes. But they rely on assumptions, imperfect inputs, and ever-changing data sets. This introduces a profound tension. The more important the issue, the more ethical weight it carries, the less science can safely test it. And so the biggest truths remain elusive, not because science is weak, but because it has inbuilt limits, and humanity demands we proceed with caution. Part 3. Cognitive and conceptual limits, the questions we don't even ask. Now we shift to something subtler, the limits inside our own minds. Thomas Kuhn, the American physicist turned philosopher of science, wrote The Structure of Scientific Revolutions, one of the most influential books of the 20th century. He argued that science doesn't simply advance through accumulation of knowledge, but through periodic paradigm shifts, revolutions in worldview. When enough anomalies arise that the current theory can't explain, the model collapses and a new one replaces it. Think of how Ptolemaic astronomy gave way to Copernicus, or how Newtonian mechanics yielded to Einstein's relativity. But here's the twist. While we live inside a paradigm, we are mostly blind to its assumptions. What if the very questions we consider valid are dictated by invisible frameworks? Consider the Sapir-Whorf hypothesis, a concept from linguistic anthropology. Edward Sapir and Benjamin Lee Whorf proposed that the structure of our language shapes how we think. If a culture lacks a future tense, does it conceptualize time differently? If a language has 50 words for snow, does it perceive snow more richly? And intriguingly, if a language lacks a word for a particular colour, can its speakers even see it? Studies of certain indigenous languages, like the Himba people of Namibia, show that without a distinct word for blue, participants struggle to visually distinguish it from green. This suggests language doesn't just describe reality, it constructs it. This is not just academic musing. It shows us how deeply our cognition is tied to frameworks, cultural, linguistic, and even mathematical. Kurt Gödel, the Austrian logician and friend of Albert Einstein, stunned the world in 1931 with his incompleteness theorems. Gödel proved that within any sufficiently complex mathematical system, there will be truths that cannot be proven within that system itself. This was not a technical glitch, it was a fundamental revelation. There are limits to what logic and reason can deliver. Some truths are beyond the system. Science thrives within systems. But what of the truths beyond? Part 4. Whole Systems and Holism, the failure of reductionism. Science often works by breaking things down, reducing the complex into the simple. But what if life doesn't cooperate with that method? Professor Dennis Noble, an eminent British physiologist and systems biologist, spent decades researching the human heart. He was one of the first to develop a mathematical model of cardiac cells. But over time, his research led him to question the reductionist dogma that genes alone elicit and dictate life. In his book, The Music of Life, Noble argues that living systems are not mere collections of parts, but dynamic networks of interactions. Genes are not in charge like a conductor of an orchestra. Rather, they are like musicians in an ensemble, responding to and shaped by the performance itself. He writes, "There is no privileged level of causality in biology. In other words, no single part, not even DNA, can explain the whole. Life is more than the sum of its molecules." This has deep implications. It challenges the central dogma of molecular biology. It pushes back against the view that understanding all the pieces, atoms, neurons, genes, will one day solve consciousness or cure every disease. In complex systems, feedback loops emerge, synergies arise, and sometimes causality isn't even clear. Does thought cause brain activity? Or does brain activity cause thought? Or is that distinction itself flawed? Kabbalah, the ancient Jewish mystical tradition, understood this in metaphor. The world is said to be formed through sephirot, 10 interdependent emanations or attributes of the divine. None can be understood in isolation. They only make sense in relation to each other. The whole is sacred. Modern systems science is slowly arriving at this view, but mystics were there millennia ago. Part 5. Paradigm collapse, when the map no longer works. So what happens when our models stop making sense? When reality no longer conforms to the assumptions we've built? Michel Foucault, the French philosopher and historian, examined this in The Order of Things. He introduced the idea of epistemes, underlying structures of knowledge that shape what is even thinkable in a given era. We don't just see with our eyes, he argued. We see with our culture, our training, our moment in time. When a new episteme emerges, it doesn't just add knowledge, it rewrites reality. The shift from Newtonian mechanics to Einstein's theory of relativity was one such break. Newton saw time and space as fixed, a clockwork universe. But Einstein showed that time bends, space curves, and light obeys its own logic. Then came quantum mechanics. Here things got stranger. A particle might exist in multiple places at once, until observed. Electrons tunnel through barriers. Entanglement connects particles across galaxies. Certainty vanished. Probability ruled. Niels Bohr, the Danish physicist and one of the fathers of quantum theory, once said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." And yet we use it every day in lasers, smartphones, MRI machines. The takeaway? Our deepest models may work without actually explaining. In Jesus and Kabbalah, the Lost Kingdom, I write about similar paradigm shifts in the spiritual realm. I argue that Jesus did not found a new religion, but revealed the hidden mystical path within Judaism, a path of internal transformation rather than external law. This shift from law to spirit, from dogma to experience, mirrors the shift from classical to quantum. The old map is useful until it isn't. Part 6. Ancient Science. Knowledge as Transformation. At this point, it's worth asking, before the modern scientific method, how did humans seek knowledge? The answer is through transformation, not measurement. In the ancient world, to know something meant to become attuned to it. In the mystical traditions of Kabbalah, Sufism or Vedanta, knowledge was not about acquiring facts. It was about understanding and changing the knower. Take the concept of dvukut in Kabbalah, cleaving to the divine. To reach this state was to align one's internal being with a higher energy, a deeper order of reality. This was echoed in the teachings of Jesus. In my book, Jesus and Kabbalah, the Lost Kingdom, I highlight how Jesus spoke of the kingdom of God not as a place, but a state of being. The kingdom of God is within you, he said, a radical statement that shifts the search for a connection with God inward, away from the outward practice of religious rituals and man-made dogma. In this model, the goal isn't to manipulate the world, but to harmonize with it. Truth is not objective data, it's a spiritual resonance. We can see parallels in Eastern philosophy. The Tao Te Ching, attributed to Lao Tzu, opens with the line, "The Tao that can be spoken is not the eternal Tao." For Lao Tzu, the Tao is the flow of life, life as an energy, a vibration. Here too, truth is unspeakable, it must be lived. Just as you cannot know music by analyzing a waveform, you cannot know the divine by equations. This challenges the very foundations of scientific epistemology. What if the most important truths are not those we discover, but those we embody? Part 7. The Hard Problem. What is consciousness? Let's return now to perhaps the most profound limit of science, consciousness. David Chalmers, an Australian philosopher at NYU, coined the term the hard problem of consciousness. While neuroscience can explain some limited aspects of brain function, memory, attention, perception, it cannot explain why these processes are accompanied by subjective experience. Why does pain hurt? Why does colour appear? Why do we have an inner life at all? This isn't just a technical glitch. It's a profound riddle at the heart of existence, and it may be insoluble from within the current scientific paradigm. Chalmers suggests consciousness may be a fundamental property of the universe, like space or time. Some theorists, like Giulio Tononi, proposes integrated information theory, where consciousness is a measure of a system's ability to integrate information. But even this stops short of explaining awareness. As philosopher Thomas Nagel famously put in his essay, "What is it like to be a bat?" No amount of objective data can tell you what it's like to be another creature. And yet our entire lives are lived from the first-person point of view. It's not peripheral to reality. At one level, it is reality. Mystical traditions have long said this. In Advaita Vedanta, a school of Hindu philosophy, the ultimate truth is consciousness itself. The individual self, Atman, is not separate from the universal, Brahman. The appearance of separation is illusion, what it calls Maya. Kabbalah similarly teaches that all of reality emanates from Ein Sof, the infinite, and our soul is a spark of that infinite light. These traditions do not solve the problems of consciousness, they dissolve it by beginning from the premise that consciousness is primary, not derivative. Part 8. Who am I? Science and the Self. So what happens when science begins to unravel the very notion of a self? Cognitive science increasingly argues that the self is an illusion, a construct, a byproduct of brain processes. Neuroscientist Anil Seth describes the brain as a prediction machine, constantly updating its internal model of the world. The self, he suggests, is just the brain's best guess about what's going on inside. This is echoed in Buddhism, which teaches anatta, no self. The sense of a fixed, independent identity is seen as a delusion that leads to suffering. Yet we all feel like a unified I. We remember, we plan, we feel responsible, we suffer. Science can explore the mechanisms of memory, but not who remembers. It can trace neural correlates of emotion, but not who feels. It can describe the voice in our heads, but not who is listening. The philosopher Galen Strawson challenges the view that the self is an illusion. He argues that the experience of selfhood, continuity over time, is so direct, so undeniable, that any theory denying it must be wrong. I examined this tension in my book EGOdemic, The Silent Pandemic of Our Minds. I argued that the ego, the false self, dominates modern life and is the source of much of our suffering. But beneath it lies something deeper, the soul, the witness, the spark, peace and fulfillment, the absence of suffering. Here is what I wrote. It is not ego, not thought, not memory that is the source of your being. It is life itself, that inexplicable energy that is conscious of being. In this light, the scientific stripping away of the self may be a necessary stage, like peeling an onion layer after layer, until we confront the mystery at the core. And that mystery is not a conclusion, it's a beginning. Part 9. The Illusion of Objectivity. Who is looking? Objectivity is often held as the gold standard of science. But we must ask, can we ever truly remove the observer? Werner Heisenberg, one of the fathers of quantum mechanics, formulated the uncertainty principle in 1927. It showed that certain pairs of physical properties like position and momentum cannot be both known precisely. Crucially, this wasn't due to a flaw in instruments, it was a fundamental property of the universe. The act of observation alters the reality observed. This shattered the Newtonian dream of detached, passive measurement. The Nobel Prize physicist Niels Bohr responded with the idea of complementarity. That reality may manifest in mutually exclusive ways depending on how we look at it. The observer and the observed are entangled. And this entanglement is not just theoretical. In quantum physics, the double slit experiment reveals that particles behave differently depending on whether or not they are being watched. John Wheeler, a theoretical physicist from Princeton, took it further with the participatory anthropic principle. He suggested the universe requires observers, that consciousness is not a passive recipient of reality, but an active participant in it. This flips the scientific worldview on its head. If there is no truly objective observation, then even science is a form of storytelling, a disciplined, peer-reviewed, mathematically formalized story, but a story nonetheless. And perhaps this is not a weakness. Perhaps it is what makes science human. So where does this leave us? If objectivity itself has limits and may be said to be an illusion, if the observer cannot be separated from the observed, then what kind of knowledge can we truly trust? In part 2, we go beyond science into the realms of myth, soul, meaning, and mystery. We'll explore some of the biggest questions humanity has ever asked. Why is there something rather than nothing? What is life, really? Can suffering ever be explained? And what lies beyond knowing? If you found this all thought-provoking, consider liking the video, leaving a comment below and sharing it with someone who loves to question the world and themselves. Please subscribe and click the notification bell because part 2 is where the journey deepens. Thank you for watching and spending time here on Philosophy Point, because where science ends, something far deeper begins.